Now there is one table. So for example, employee table is there. Okay, there is a request. So in employee table, there is 1 million records. 1 million records are there. Okay, and there are 100 users. User 1, user 2. Like this, user 100. Okay, all users wants. There is one query. So they all want. Select star from employee department number equal to 10. They all want to see the results of this department number 10. First, so in 1 million records, if you search this query, so let's say it will fetch 1000 records. Okay, in 1 million records, it needs to search 1000 records. So it is a performance issue, right? So for searching the 1000 records from 1 million records and it will display, that is some little bit performance issue. Okay, one time it is okay. Then second user also same query, third user also same query, fourth user also same query. Like that, 100 users same query they are running at a time. Same query they are running on same table. So this is also this 1000 records also it will search for 1 million records. Again 1000 records will search for 1 million records. Again 1000 records it will search for 1 million records. So the search engine will go the request from user to database. It will be more. The requests from user to database is more, and searching also from 1 million to 1000 records. This is also very more. So this due to this, the performance will be reduced of the database. So see, think practically in 1 million record searching of 1000 records. So it will not be in order, any order. It will be in any order. So it needs to search all records and it needs to fetch 1000 records. One time it is okay, but if the 100 users are requesting same select query, so this week performance will be degrades. Okay, so 100 users one time, that is okay, but 100 users they are executing the select query 100 times. 100 into 100. 100 into 100, how much? 10,000 times. So 10,000 times same query should be executed and same result should be displayed from the database. So where the table stores? Database. So if you write any select query, it will go to the database directly. So the load will be more in database and the performance will be decreased. So for that, what will be the option to improve the performance? Okay, if we create a view on same query, if we create a view on same query, first it will store some cache memory. There will be some cache memory. So these 1000 records will be stored here. 1000 records will be stored here. So I have created a view. Select star from v_10. So for this query, I have created a view and I am searching this view data every time. Every time I am searching from this view for the first time execution of this view. So the data will bring the 1000 records will bring from main table only first time to cache memory. Okay. So from next time onwards, whenever you are searching this view, select star from v_10, every time the data will bring from cache memory only. So those 1,000 records only it will bring. So if we create a view and if we give access to all users, user 1, user 2, user 3, user 4, like this all users. So whenever the user executes this view, so directly the data will bring from the cache memory itself. It will not directly go to the table one. Sorry, it will not directly go to the DB. Due to this, the performance will be improves. You should know the concept. That's it. So the creation of view and everything is simple only, but you should know why we create a view and what is the use of view. Now I will show you how to create a view. View is nothing but virtual table. This is a virtual table. Okay, whatever we can see, that is a view. Whatever you can see with your eyes, that is a view in normal terms. Okay, so for the first time, the definition. This is the creation of view. There are three types of views: simple view, complex view, first let's see simple view and complex view. Simple view means the view can be created in one table. Complex view means the view can be created more than one table. Two or three more tables, two or more tables. Okay. Creation of simple view. Create, replace view. View name as select query. This is the simple query. So like I said previously, so here there is a department number 10 query. Not only department number, anything, but whenever the user is requesting more times and whenever the more users are requesting the same query, so at that time you can create a view. Create or replace view. View name I am giving view underscore 10. Yes. Start from view fitting where view number equal to 10. This is the simple view. Create or replace. Why we are using create or replace? If view is exist, then it will be replaced. Okay, if it is present, it will be replaced. If it is not present, it will be create. Okay, now view created. Here select star from view underscore 10. Created created on department table, so we will create employee table. It is also okay, but in employee table there is more data. So start from view 10. See, every time if you are executing 100 times also view, so the same result will come. So for the first time, this data will be stored into the cache memory. From next time onwards, whenever you are executing the view, 100 users are executing 100 times also, it will, the request will go to the cache memory, and from there onwards it will bring the data. Okay, so clear the concept view.
Yes.
ఏదైనా సరే క్యాష్ మెమరీలో స్టోర్ అవుతుందా బ్రదర్?
క్యాష్ మెమరీలో స్టోర్ అవుతుంది, అక్కడ నుంచి డేటా తీసుకొస్తుంది. నెవర్ ఎగ్జిక్యూటింగ్ వ్యూ. But the cache memory is not permanent. So in our so if whatever you search in Google, so for example we have searched for the Oracle questions, Oracle interview questions in Google. So whenever next time you open Google, it will give suggestion, means that it will store into the whatever you searched in Google, that will be stored into the cache memory. So whenever you clear the history, or whenever you clear the cache memory, so that data will be gone and you will not be able to find there. So in the same scenario here also, view also. Okay, but here this is not a permanent. This cache memory is not a permanent, so it will have minimum size. For example, let's say it is 1 GB, the memory they have given. So this memory taken care by DBS, database administrators. Okay, let's say this is a 1 GB. Okay, this 1000 records fit now. Again we have created one view that view contains the 1 million records. So that view also should store in the same cache memory, right? That view also should store in same cache memory. So now those 1 million records will be stored here, and this 1000 records will be removed from the cache. But next time whenever you are executing this view, from where it will bring? It is not present in cache memory, so it will directly go to the main table only. Okay, then that is also one drawback, right, for view. So to avoid that, we are having another concept. This is advanced topic, materialized views. Okay, that we will discuss later. Materialized view, just understand the concept of view. So it will first time it will go to the main table, and after that it will store into the cache memory. So whenever you are executing view, it will bring from the cache memory itself data. Okay, once the cache memory full, so again whenever you are executing view, it will go to the main table only, because the cache memory is full and there is no data, there is no view data. Okay, this is the simple view. Okay, now I want to complex view. Here only I will explain directly. So here I have created this view created, select star from v underscore employee. First time execution of view, data will bring from main table and it will store into the cache memory area. From second time onwards, whenever we are executing view, data will bring from cache, not from the table. It will improve the performance. Okay, that is the simple view. Now, does the view contains the data? Does this view contains the data? No. This view does not contains the data. It will bring from somewhere else, either cache memory or either table. Okay, so this view does not contains the data. Just remember that point. Normal view that does not contains the data. Can we do DML operations on simple view? If yes, then what will happen to the main table? Means we have created a view. Select R1. This is the view. Okay, so if we are updating something here, first of all, is it possible to update here? Okay, second thing, if we update here, what about the main table? That is we need to understand. So I am updating here, update v underscore 10 set salary equal to 6,000, here salary equal to 5,000. So I am updating the salary 6,000 where the salary is 5,000. It is updated. Let's see. Okay, the answer is yes, we can update we can do DML operations on the view. Then what about the main table? So can anyone guess? This is not a main table, so we have created from main table and we have updated the thing in view. But what about the main table? In employee table there will be a 5,000 or 6,000.
5,000.
6,000. The main table also will get update if we update on view. So we can do DML operations on this table. Next thing. Okay. Next thing is the complex view. Complex view is nothing but create the view on one or more tables. Like we said previously, select employee number. We are having a query employee number, employee name, salary, department name, location. These are from two tables, from employee department D, where E dot department number equal to D dot department number. This is our select query. So previously also we are fetching the data from one table, but now we are fetching the data from two tables. So if the same 100 users executing 100 times from the two tables, this will be a huge impact on the database. Okay, for this also we can create a view, that is a complex view. So if we create view on more than one table, then that is a complex view. Create or v underscore y, something I have given name. As keyword is missing. As start from v underscore em. See, how many times we executed, it will bring from the cache memory till the cache memory fulls. Once the cache memory full, the data will be removed. Okay, clear? Complex view.
Yes, bro.
If there is any aggregate operations, okay. So the complex normal view we can update, but complex view we can update if there is no any aggregate functions. What are the aggregate functions? Aggregate functions in variety.
Min, max, count, sum, average.
Yeah. If whenever you are using that aggregate functions in select query for the complex view, so at that time we cannot update the view. So otherwise we can update the view and we can delete the view and we can insert the data into the view. Simple view we can insert directly, but in complex view we cannot insert the data, because if we are inserting the data into view, these columns are in one table and these columns are in one table, then where the data will go? So that is why complex view we cannot insert the data. Okay, in simple view, we can insert the data. So this is the concept of view. Now, if the cache memory fills, then what is the next step? The view, again, it will go to the main table, and again, it will bring the data from there. Okay, this is also will cause the performance issue. So to avoid that, we are having a materialized view. There is a materialized view concept. So whenever you create the materialized view, the data will be stored into the, so the DBA persons, they will create a one materialized view log. This log, materialized view can be created by the developers, but the logs will be created by the DBS. So just listen the topic. That's it. That's enough. MT materialized view log. Whenever you have created same thing for the same select query, I have created a materialized view. Select star from MV underscore 10. I have given the MV. Okay, whenever you have created this, so at the time of creation only, the data will be stored into the materialized view log. This is a physical data, physical storage, but this is a logical storage. Cache is a logical storage, and a materialized view log is the physical storage. Now, does the materialized view log contains the data? Yes, the materialized view log contains the data. Okay, here we can store the data, and whenever we are searching the data from the materialized view logs, it will not go to the main table. It will bring the data from the materialized view logs itself, due to which the performance will be improved. Okay, so now we can show you how to create the materialized view. There is also one simple syntax only. This is the syntax. Okay, first I will show you. Simple materialized user materialized view with the same user name already exists. So start from employee web department. Just a minute. So what I'm doing mistake, can anyone correct me? How to add primary can table? Need to give bracket. So now Materialized view is created. Start v underscore underscore 10. Okay. Now this data, where the data is stored. So now we cannot create a materialized view logs. So this total DBS can do. So in real time, they will create the materialized view logs. And whenever you have created the materialized view, so it will store into the materialized view logs. So now, as per here, the 1000 records will be stored into the materialized view logs. So it cannot be deleted until and unless we can delete the data. Okay, because this is a physical storage. Materialized view log is the physical storage. So if the 100 users are requesting the data from 100 times, so 100 times the data will bring from the Materialized view logs itself. It will not go directly to the main table. But here one thing is, there is a view also, I think. Select star from MV logs means materialized view logs. Materialized view logs.
అంటే ఫైల్స్ అన్నది టెక్స్ట్ ఫైల్స్ లాగా
టెక్స్ట్ ఫైల్ కాదు, ఇది ఒక ఫిజికల్ స్టోరేజ్ అన్నమాట. ఫిజికల్ స్టోరేజ్, డేటాబేస్ లో ఒక ఫిజికల్ స్టోరేజ్ అది, అంతే. అది డిబిఏ వాళ్ళు క్రియేట్ చేసి ఇస్తారు. సో మనం దాన్ని మెటలైజ్డ్ క్రియేట్ చేసినప్పుడు ఆటోమేటిక్ డేటా అనేది అందులో స్టోర్ అవుతుంది. ఇప్పుడు ఒక టేబుల్ ఎలా ఉంది, టేబుల్ లాగే మెటలైజ్డ్ లాగా, అంతే.
ఓకే అండి.
ఫర్ స్టోరేజ్ పర్పస్. సెలెక్ట్ స్టార్ ఫ్రమ్ v_10. For the same scenario, we are having one materialized view and one normal view. One is materialized view and one is normal view. Now what I'm doing, I'm updating in the main table. Update emp set salary equal to 6000. Set salary equal to 6000, where salary equal to 5000. I'm updating it into the main table. I have updated. Select star from. See, in place of 6000, I have updated. Sorry, in place of 5000, I have updated to 6000. Then what about the materialized view? What about the main view? First we'll see. So the main view also updated. The view also updated. Then what about materialized view? Materialized view is not updated. So to see the updated results, what we need to do? There is a refresh mechanism. Refresh the view. Until and unless you does not refresh the materialized view, you cannot see the updated results. So here you need to refresh the materialized view. That this is the package, execute dbms mview dot refresh. You need to give that materialized view name, mv underscore emp, sorry, ept underscore 10. That is only now our name, mv underscore dbt underscore 10. Yes. Successfully completed. Now see, See, now you can able to see the updated results. Okay, clear the concept? So whenever you changed anything into the main table, it will immediately reflect into the normal view, but in materialized view, it will not reflect immediately. So to see the updated results, you need refresh the materialized view. Refresh is mandatory. Until and unless you does not refresh the materialized view, you cannot see the data. Okay, clear? This is the concept of view and materialized view. So here in Materialized view, there are some options. While creating only, we can create refresh, on commit, on demand. If we create on commit means whenever we are committing into the main table, automatically it will be replaced. It will on demand means like this. On demand means we need to refresh the Materialized view manually. Fast refresh, complete refresh, force refresh. These are the options for the refresh. Now, anyone having any doubt on normal view and Materialized view, how it works? Creation is simple only. There is a one syntax only for normal view and Materialized view. There is only syntax. We need to follow the syntax. That's it. But concept wise, you should remember. You should know concept wise why we create view and why we create a Materialized view. Materialized view. Clear? Any doubts on this?
వ్యూలో ఒకసారి స్టోర్ అయితే అది డేటాబేస్ లోకి వెళ్ళిపోయి మళ్ళీ డేటా తీసుకుంటుంది అన్న.
డేటాబేస్ లోకి వెళ్ళదు. వ్యూ క్రియేట్ చేసినప్పుడు ఆ వ్యూలో ఏ డేటా అయితే ఉందో ఆ డేటా అనేది క్యాషే మెమరీలో స్టోర్ అవుతుంది. క్యాషే మెమరీ అనేది లాజికల్ మెమరీ, ఇట్ ఇస్ ఏ టెంపరరీ మెమరీ. సో ఎప్పుడైతే ఆ యూజర్ను ఆ వ్యూ నుంచి యూజర్స్ డేటా రిక్వెస్ట్ చేస్తున్నారో అప్పుడు క్యాషే నుంచి తీసుకొస్తుంది, డైరెక్ట్గా టేబుల్ దగ్గర నుంచి వెళ్ళదు. అసలు ఎందుకని తీసుకురావాలి? మెయిన్ టేబుల్లో 1 మిలియన్ రికార్డ్స్ ఉన్నాయి, కానీ మనం సెర్చ్ చేసేది 1000 రికార్డ్స్. 1 మిలియన్ రికార్డ్స్ లోంచి సెర్చ్ చేసి 1000 రికార్డ్స్ డిస్ప్లే చేయాలంటే డీబీ లోడ్ ఎక్కువ అవుతుంది. డేటాబేస్ లోడ్ విల్ బి మోర్ అండ్ ద పర్ఫార్మెన్స్ విల్ బి డిక్రీజ్. సో ఫర్ దట్ రీజన్, if we create a view, the 1000 records only it will store into the cache memory. So whenever you are executing the view, the 1000 records only it will bring from the cache memory. It will not search from the whole 1 million records. That is the main purpose. But if the cache memory is temporary memory, if the cache memory fills or the retention period is crossing, then the view data will be deleted, right? So to overcome this, we are having materialized view concept. Same thing, it will store into the physical storage. Materialized view logs are the physical storage. So we cannot be deleted until and unless we can delete manually. Clear everyone?
Yes, sir.
Yes, sir.
Now I will show you. Grant, revoke or left, right? Grant, revoke, DCL commands. Remember DCL commands? Data control language. These are the grant,
Revoke.
First I will show you how to create the user. Create user, granting the roles, revoking the roles, granting the roles, revoking the roles, and synonyms. These things I will show you. Show user. My user is system. Currently my user is system. The system user contains the employee table and department table. select star from employee, select star from department. There are so many tables, but I am telling now the system user, show user you can see. So in which user you have logged in, that you can see show user. Okay, the system user contains the employee table and department table. Owner is the system owner. Now I am creating the another user. Create user. I am creating my user drop. Oh, sorry, creating user Raghu. I am giving my name user Raghu, identified by. So this is the password. Raghu is the username and Raghu123 is the password. User Raghu conflicts with another user or role name. Okay, another user already is there. User. User drop. So now I am creating again, create user Raghu identified by Raghu123. Now user created. So how to connect to the user? How you are connecting daily? Now I want to connect to the Raghu user. How to connect?
Connect.
Connect. Username. Password.
Enter username, password.
Okay. So we have created a user. Okay. But we don't have a privileges, login privileges. We need to give the privileges first for logging. So grant is we are giving the permissions
Permissions.
for what? Connect comma resource. These are the permissions whenever the user created newly we need to give to connect the session. Grant connect resource to Raghu. Okay, not connected means first we need to connect system because we tried to connect to the Raghu, right? So it is disconnected. See show user, no user is there. First we need to connect to the system main user. System/manager. Okay, now I connected and I am granting the privileges. Grant connect resource to the Raghu. Grant succeeded. Now try to connect. Connect Raghu, comma slash Raghu123. Now connected. Now I have connected to the Raghu user. Now see show user. See user is Raghu. The user newly created. This user does not contain any database objects. See select star from employee. No table. Select star from department. No table. So we want to access the system user employee table. To access that, to give system dot employee. Tabular view does not exist. Still I'm not able to access. I'm opening another SQL window. Here I'm connecting with system. Okay. So system is having select star from employee. System is having employee table, but that system table I need to access. Select star from system dot employee. So table view does not exist because this is Raghu user is not having the privilege to access the system employee table. So we need to grant the access. Grant select on employee to Raghu. This is the command. Grant select on employee to Raghu. Grant succeeded. Now see, now execute. Now you are able to access. Now Raghu user is able to access the table. If you give directly employee, it will not accessible. If you give system.employee, system is the user. System.employee, he is able to access because the system gave the access to the Raghu user. Revoke. Select on employee. Revoke succeeded. Now again the roles are taken back. The roles are revoked. Okay, clear everyone? Grant and revoke. Grant means to give the permission. Revoke means to revoke the permissions. Clear?
Yes, bro.
Yeah. So I am giving this grant. Only select the permission I have given. So now can I delete some data here? See. So I am doing delete or update anything. I am doing update emp system.emp set salary equal to 5,000. Equal to 6,000. Here 6,000 is there, so I am updating 5,000 in place of 6,000. What is showing? Insufficient privileges. We have given only select rights. We have not given any DML rights to the user. So we need to give the privileges. Insert, update, delete. Grant, insert, update, delete an employee to Raghu. Now grant succeeded. Now update. One row updated. Commit. See, 5,000 is there. Then what about the main table here? This is also updated. Okay, if you want to revoke, insert, on employee from Raghu. So revoke succeeded. Now if you want to update, insufficient privileges, you will not be able to update. So that is about the grant and revoke. So this is Raghu user is the remote user who is accessing the table of the system. System is the remote table, remote user. Okay, now instead of writing here every time system.employee, system.department like this, instead of writing here, I will create a synonym. Synonym is nothing but alias name for the table. Alias name for the DB object. Not only table, we can create this procedure also. We can create this for view also. What are the DB objects? Tables, views, synonyms, sequences, all are the DB objects. There is a syntax to create the synonym. Create public synonym. This is the syntax. Create public synonym, synonym name. Anything you can give employees for employee. So I am creating the synonym. Where I am creating in original place. System. In this at the user system. Now synonym created. Now see select star from. This is synonym. Synonym is nothing but alias name for the table. So if you can see select star from employee, you can see by using synonym also you can see. Okay. Now you have created a synonym here. Will you be able to access here? Yes, you'll be able to access. Okay, synonym is nothing but alias name for the table, and we can use this for remote objects, remote database. We can access their table remotely. This is one purpose, and another purpose, if there is any table long length names. So one is to access the remote tables, and another one is to shorten the long length table names. For example, there is create table. This is the table name. Okay. So every time we no need to access this much table name. So simply I have created a synonym, create public synonym test for this. So directly I can access by using select star from test. That is the purpose of synonym. Now clear everyone? What is grant, what is revoke, and what is
Yes.
synonyms?
Yes.
Clear, right? Here we have discussed views, materialized views, ETL commands, sorry, ECL commands, synonyms. Okay. I think someone asked me SQL index. They need SQL index. Here only I'll write here now. Topics in SQL. Data types. DL commands, DML commands, ECL commands, ECL commands. Strings. Next thing is indexes. Related functions. So all everything we have covered except the indexes. Okay. Indexes with little bit performance tuning. We will cover tomorrow. Indexes and little bit about performance tuning, how to see the execution plan and everything. So once we complete these topics, there is SQL loader. Okay, these two topics are left, indexes and SQL loader. So this is all in SQL topics. PLSQL topics I will tell once the PLSQL class is started. So tomorrow indexes will be completed, and the day after tomorrow SQL loader will be completed. In 2 classes we can complete the SQL. Okay, any doubts till here?
No.
Anyone having any doubts? Whatever you are having while practicing or any doubts you are having, just note it down and ask me at the end of the class. I will give you 5 to 10 minutes after the end of the class. You can ask me at the time only.
Okay, bro.
Because in the daytime I will be very busy, so I'm with office work, so I'm not able to answer the questions. If someone is asking the questions to me, I'm not able to answer them. That is the reason I'll give you 10 minutes after the class, so you can ask at the time only. Clear?
Yes.
I'm stopping the session. Bye.